everybody, and welcome to the Chemistry 121 Supplemental Instruction series of videos. I'm Smokey, and in this episode we're going to be taking the multimole conversion concept, taking it a little bit further, and doing an actual problem with it.
So we're going to get to work with the mole ratios.
Yes, we are.
Alright. By the way, I'm Kevin Martin.
And we'll be presenting this episode.
Okay, so I see, of course, we have a chemical equation here.
Yep. All balanced and everything.
Well, geez, that cuts out a lot of work for us.
Absolutely.
Alright, and let's see. So 15 grams of H3PO4 to however many grams of this stuff.
Yes. So basically, we're just saying we have 15 grams of phosphoric acid as our reactant, and we're trying to figure out how many grams of the salt we're going to get as our product.
Okay.
Now, Kevin, what kind of a reaction is this?
Double displacement.
Yes. Also, it is
acid base.
Absolutely, because we have phosphoric acid here, barium hydroxide, which is the base, and we get a salt and water, which is always a characteristic for an acid-base reaction.
Yeah, that makes sense.
Okay? So, how are we going to do this conversion?
Well, I guess for starters, we start with the given amount.
Absolutely. I'm going to write kind of small since we got to fit so much on the board here, but make sure you write along, jot down some notes as we go.
Alright.
So, 15 grams of phosphoric acid is what we're going to start with.
Alright.
Okay? And remember, I always put it over 1, that way we know exactly what we're working with.
Okay.
Okay, now, what are we going to do after that?
Let's see. Well, you can't directly compare grams of this to grams of this, I'm assuming.
Right, you can, because they're two different things.
Yeah. Okay. So, you can compare moles, though.
Yes.
Mole ratio.
Mm-hmm.
So, I guess you would use the molar mass to convert this to moles.
Yep, exactly. So that's what we're going to do. And in order to set that up, basically we just put moles of the phosphoric acid up here on the top. And then, of course, we'll have the grams down here since we're trying to get rid of grams. We're canceling it out. Okay? And to save you guys from the math, we did this beforehand. It's going to be 98 grams of H3PO4 for every 1 mole of it. And as you can see, this is a molar mass conversion right here.
Yes.
Yep. And by the way, if you want to review how to get molecular weight and all that, make sure you check out that episode.
Okay.
Okay, so what next?
Well, since you said something about mole ratio, I assume that's going to be our next step.
Yes.
And we're going to need a ratio of the barium phosphate to the phosphoric acid.
Yes, exactly. And since we're trying to get in terms of this, basically we're going to be canceling out the moles of the H3PO4. So again, remember, just deal with your units before you start putting numbers in. So moles of phosphoric acid here.
Okay.
And then you're wanting to put moles of that stuff up there. Okay. So then comes the question, what are you going to do about the numbers?
Well, if I remember correctly, you're going to look at the coefficients in the equation.
Essentially, that's it.
So, let's see. Barium phosphate. Well, there's a 1 there, so it would be 1 mole of barium phosphate.
Exactly.
And the phosphoric acid to 2 moles of phosphoric acid.
Precisely.
Alright.
Okay. So let's go ahead and see what we have canceled out so far.
Okay.
We got rid of grams of phosphoric acid. And we've got rid of moles of phosphoric acid.
Okay.
So now we're in terms of moles of the salt.
Alright. But we want grams of salt, right?
Yes.
Well, we now have moles at this point, so we're just going to convert it to grams of the salt using molar mass of that.
Exactly. So we can go ahead and do that next. So, and as you can see, this problem did get pretty long, and it gets that way. One note, though, make sure you write all your units out. I know that it's easy to get lazy and all that sort of stuff, but it's really important when you do stoichiometry problems like this, mole-to-mole conversions, make sure you write everything out so you know exactly what you have and you're less likely to make mistakes.
And that's always good.
Yes, absolutely. Okay, so back to this. We have moles of the barium phosphate down here, because we're trying to cancel it out, right?
That's right.
Okay, which means we're going to stick the grams up here. PO42. That's a bunch of stuff.
Yeah, that is a bunch of stuff.
Yeah,
how much does that weigh?
That weighs 601.9 grams.
That is heavy.
That's a pretty big molecule.
Wow.
601 grams for every 1 mole.
Wow, that's a lot.
Pretty amazing, isn't it?
Yeah.
So, yeah, I mean, big molecules can get that way. Especially phosphate. It's going to be one of the bigger things that you're going to be dealing with. Okay? So, we got rid of the moles of the barium phosphate, leaving us with the grams, which, guess what? That's what we were looking for in the problem.
Alright.
Okay?
I guess at this point, all that's left is plug and chug.
Plug and chug, that's right. So, let's see here. That divided by that, times that. We get a grand total of 46 grams of that stuff.
Wow, that's...
PO4.
Alright.
2. And there we go. So even though we started with, 15 grams of this stuff here, we ended up making a whole bunch more of the other stuff.
Yeah.
That's why we do mole-to-mole conversions, because, it's pretty tricky. You wouldn't expect to get a number like that. But that's how it works out.
Yeah, I mean, it makes sense. You have such a big molar mass right there.
Absolutely. Yes. Okay. So, there we go.
Alright, very cool.
Mole-to-mole ratios in action.
Alright.
Awesome stuff, huh?
Yes, indeed.
Why don't we go carry this out in the lab?
Why not?
Yeah, let's go see what happens with it.
Cool.
All right, see you later.
Yeah.